I'm going to quickly start this video by saying that this is question 9 of your homework. The equation kx squared plus 4x plus 5 minus k equals 0, where k is a constant, has two different real solutions. So what this means is that from two different real solutions, we know that our discriminant of b squared subtract 4ac has to be greater than 0. What do we do from here? Well, I want to first of all outline what my values of a, b and c are going to be, and I'd encourage you to write this out as a equals k, b equals 4 and c equals 5 subtract k. This means now clearly I'm just going to substitute in, and I'm hoping that when I do that I can rearrange it to give me this form. That would be the show that. So what I'm going to do is I'm going to start off with my b squared subtract 4ac is greater than 0, and I'm going to substitute in the values of k, 4 and 5 minus k. So I get 4 squared, subtract 4 lots of a, which I know is k, subtract 5 minus c, so 5 minus k, and that's got to be greater than 0. So now it's just a bit of expanding. 4 squared is 16. Take away, well, 4k multiplied by 5 is take away 20k. And then 4 multiplied by k multiplied by negative k is going to give me positive 4k squared. And I know that this is greater than 0. Just thinking about this in terms of their terms, this is 4k squared, take away 20k plus 16. So I'm just going to rewrite that just up here. So it's 4k squared, take away 20k plus 16. But this isn't quite what they wanted. They wanted k squared, subtract 5k plus 4. So what I'm going to do is I'm going to need to divide each term by the same constant, and that's going to be 4. So dividing by 4 is going to give me k squared, take away 5k plus 4 is greater than 0. Okay, perfect. We've done part A. We've shown that k satisfies this equation. Now it says, hence find the set of possible values for k. Well, if we want this to be the case, we've got a quadratic inequality. So the first thing I'm going to do is solve this to find the intersects or the roots, and then I'm going to think about the equality and what it means by graphically. So part A here is done, so I'm going to swap over and I'm going to try and answer part B. So factorising this, I get k plus 4, k take away 4 even, k take away 4, k take away 1 is greater than 0, and that's going to give me answers for something to do with k, and that's going to be related to the positive values of 4 and 1. I don't know what that is yet, I don't know the relationship between k and those values, but I know something happens at those points. So to do this, I'm going to plot it and think about what is the parts that I actually need. So I know it goes through at 1 and 4. Let me just mark those on. And I'm going to draw this quadratic, draw the parabola, and think about the regions which I need. So drawing the parabola, I'm not too worried about anything else, as long as it goes through those points. And here we can see that if I refer back to the question, I want to know when this is greater than 0. The values which are greater than 0, well, they're going to be all the values which are greater than the y-axis. So therefore, when I come to looking at sketching this, I want to know the points which are greater than 4 and less than negative 1. Hopefully that makes sense. If I'm looking at greater than 0, which I am, which is indicated in the question, I'm looking for the bits which are higher than the x-axis. If it was less than 0, I'd obviously be looking at the opposite. So, how do I write this? I want, therefore, k is going to have to be greater than 4, because that's going to give me all of these points over here. And then I also want to be having the points where k is less than 1, because that's going to indicate all of these points over here. So it's always important when we have an inequality to try and sketch it, and then from the sketch we can work out the appropriate regions. I hope you found this useful.